Welcome everyone. This video here today will cover solving equations with modulus functions. So I've got a few really basic definitions here that will help in the really basic ones. If the modulus of x is equal to 3, that means x could be 3 or minus 3. Let's get our head around that first of all. Okay, so if x is minus 3, then this is absolutely true. Tick. So, so that one's easy, nice and easy to work out. The modulus of x less than 3, okay. Well, that means x could be anywhere between -3 and 3. And just convince yourself of that. So if x is -2, then the modulus of -2, which happens to be 2, is that true? Yes, 2 is less than 3, that's true, okay. And the last one, the modulus of x is greater than 3, okay. So that means x is greater than 3, that's obvious, or x is less than -3. Once again, just think about it. If x was -5, is this true? Is that true right there? Now if you think about it, the modulus of -5 is 5. 5 is greater than 3, so absolutely that is true. Okay, so there's a few real basic kind of definitions there that will help us with these ones. So let's look at the answers to these ones, guys. They're pretty easy. If the x is the modulus of 2, then x is just 2. Boring, basic. If x is the modulus of -2, then x is also 2. And if the modulus of x is 2, then x could be 2 or -2 for the third one. Okay, a little bit trickier. D, x plus 2 is equal to 3. Well, using the definition, that means x plus 2 is equal to 3 or x plus 2 is equal to -3, in which case we get x equals 1 or -5. So we get two solutions for D. Okay, for E, just carrying on the same way, 2x plus 1 is equal to 4, or 2x plus 1 must be -4. Okay, that's just using the very basic definition from the previous page. So in this case here we get 2x is 3, so x is 3 over 2. And over here we get 2x is -5, x is -5 over 2. Okay, so once again we've got two solutions here for this one here, just like we had in this one up here. Okay, and I'm not going to do the last one, I'll leave that one to you. Inequalities. Alright, cool. A little bit trickier. Let's try one of these. X plus 1 is less than 3. I love the graphical method in this, so I'm going to show you both methods, but I think the graphical method rocks, so I'm going to do that first. I've drawn the graph of y equals modulus x plus 1. Okay. So that is this graph here. You can see it's got the two branches. It's been translated 1 unit to the left. And we want to know when does that intersect the line y equals 3, which is of course this line right here that I've drawn. Y equals 3. And so I want to know first of all when they're equal to each other, and then when I find where they're equal to each other, I can then really simply find where the modulus graph is less than 3. And in fact, I can see straight away that the modulus graph, this bit here, is less than 3 for all of the x values between here and here. So that whole interval there. Okay, so now it's just a matter of finding when it's equal to 3. And we've just done that. So we want to solve when does this equal 3. Okay, so using our basic definition, I can say, okay, so x plus 1 equals 3. Or x plus 1 would be -3. Got it? So in this case, x is equal to 2 or -4. So that is -4. That is 2. Looks good. And my final answer is this. Note the way I'm writing it. Awesome. Okay. And I'm going to leave the second one for you to have a go at. Just work that one through on your book and see how you go. Okay, here's the answer for the second one, just check you got it right. Let's find when 2x minus 3 is equal to 4, so I've got 2x minus 3 equal to 4, or 2x minus 3 equal to negative 4, just using the basic definition. So 2x equals 7, x equals 7 over 2. That is going to be that value right there. Or in this case over here, 2x equals negative 4 plus 3 is negative 1. X, I'm sounding a bit bored here, but you got the drift. X equals negative a half. That is that value right there, negative a half. Okay, let's look at the graph here. We're looking for when is 2x minus 3, that's the modulus graph, greater than or equal to 4. Alright, I can see from the graph that it's above 4, all of the x values, all of these parts of the graph, right, that are going above the line. In other words, it's greater than or equal to 4 when x is greater than or equal to 7 over 2, or for all the x values less than or equal to negative a half, and that is the answer. Okay, what do we do with the modulus on both sides? Okay, lots of fun. There's a couple of ways of doing this. I love the graphical method here, so I'm going to show you both ways. I didn't show you both ways in the last one, but I promise I will in this one. Okay, x minus 3 goes like this, and that's 3. X plus 4 does this. Not to scale here, and that there would be minus 4. Okay, so shift over 4 to the left. We want to know when they're equal. Well, they're equal right here. That's when the graphs intersect, so that's what we're trying to find. What's that x value where the two graphs intersect? And they will have only one point of intersection because both of these are just x and x. So these lines here both have a gradient of 1, so they're never going to intersect. So we're just looking for that x value right there. Alright, how do we sort that out? Well, okay, what's the equation of this branch here? Alright, is it y equals x minus 3? No, it's not. It's y equals negative x plus 3. And we just make the negative, both of these bits here, make it negative, and there you get the left-hand branch here. And the right-hand branch of this one here is just y equals x plus 4. Cool. So then we just want to find out when does x plus 4 equal negative x plus 3, and when do those two branches, those two equations intersect each other? And I find that's when 2x equals negative 1 and x equals negative a half. Okay, that's method number 1. Method number 2, some of you will like this. When you have modulus on both sides of an equation or an inequality, you can square both sides. So if I square both sides, I get this. X minus 3 squared is x plus 4 squared. Okay, so now we've got on the left hand side here x squared minus, oops, let's change to blue, minus 6x plus 9 and x squared plus 8x plus 16. Okay, so a bit of cancelling here, and we're going to end up with, if we add 6x to both sides, that'll give us 14x, and if we subtract 16 from both sides, that's going to give us negative 7. So divide both sides by 14, and that will give us x equals negative a half, which is the solution to the problem. So there's two ways of doing that. I love the graphical way, and it really helps in the next one, but you can also do squaring both sides. I'll leave that second one for you to have a go at now. Okay, so here's the last one we've got going here. So this is an inequality one, a little bit trickier. I'm going to use the graphical method first here, which I think rocks. So I'm going to draw x plus 1, which does that, and then I'm going to draw x minus 2, which is a similar graph but sitting over there at 2. These are not to scale. Okay, so now let's just, we've got a red graph here and we've got a blue graph here. Alright, now I want to know when is the red graph below the blue graph. Really, that's what this here is saying. When is the red graph, the modulus of x plus 1, below the blue graph. So when does that happen? This is a key point right here. And I can see that every x value from that point and to the left of there, the red graph is below the blue graph. So just have a look at that geometrically and you can see how that works. So now it's just a matter of finding that point, and we know how to do that. We know that the equation of this branch here is y equals negative x plus 2. The equation of this branch here is just y equals x plus 1. And we just want to find when those two are equal to each other, when they intersect. So when does that equal that? If I add x to both sides and subtract 1, I get x equals a half. So clearly looking at the graph, I can see my final solution is we're looking for all the x values less than a half. Cool. That's the answer. This gets trickier obviously when you have questions like in B where you've got a 2x there. So I'm going to leave you to do B, and you might get an answer where you have a range of values like x greater than 1 and less than 3 or something like that. That'll come up in B. For this one here you could also square both sides. I don't prefer this method, but you can do it. So we could go x plus 1 x plus 1 squared is less than x minus 2 squared. So that's x squared plus 2x plus 1 is less than x squared minus 4x plus 4. Notice here, and this is the cool part of this one, those x squareds cancel. So this makes it quite an easy problem. Add 4x to both sides, subtract 1. And then divide by 6. 3 over 6 is the same as a half. So you can see we get the same answer using either method. The thing about this squaring this both sides method is that if you have a question like B where the x squareds don't cancel, you're going to end up with a quadratic inequality, which makes it a lot harder to do. So you choose the method. Perhaps you could have a go at both, but now I want you to have a go at part B and post your answer for that one. And that's the end of those.